Welcome back to HVAC-Engineering-Techie channel. This is the channel we talk all things HVAC, engineer design, construction, equipment, systems, test and balance extensively, controls, efficiency, and system performance. All these videos are educational in nature, designed to help you further your career and also to help you on the job. So today we're talking tab reports. Not the funniest subjects, but actually it's an important component of test and balance work. And we'll go over that and talk about that. Before we do, I really appreciate you being a subscriber if you've already subscribed. If you haven't, would you please push the subscribe button down below? It's absolutely free. It costs you nothing. It's really simple for you. And the reason I want you to do that is because Google uses that data to evaluate my videos. And having a good rep on Google is good for me, and I'd really appreciate you. So let's go ahead and get started on tab reports. All right, let's talk tab reports. A tab report, of course, is a thing that you send to the engineer or the customer to tell them what you've done and what's good and what's bad. So the exact layout of the tab report is left to the provider firm, but may also be a format required by the tab certification agency or your project specification. Tab report table of contents. Any report of any size needs to have a table of contents. It should be a cover page, table of contents, project data, certification page, report summary. It's an executive summary. A test and balance reports all those forms of test and balance you've done in the field. Layout drawings that correspond with these test and balance reports, and resumes and proof of certification. So all of that should be in your report. Instrument lists and calibrations. Which instruments did you use on the job and what was their calibrations? I know some firms just list every instrument they have. I don't recommend doing that. I recommend only using the ones you have on the job. In case you need to do some retesting and some verification of readings, you want to use the same instrument so it has the same accuracies and the same calibration factors. So the cover page is just a cover page, and you can have anything on it you want actually, but it needs to have the project name, so you know what that is. Its location, where it is, the date of the project, and the provider name, your name, and your logo on there. Sure, that's what you'd want to do. Table of contents is a list of report pages and locations. And the reason there is a little bit of a thing here is it's kind of a bad subject, but we have had instances where our customer, mechanical contractor, has actually gone in and changed our report. They didn't like our readings, or they didn't like that we put a note on there saying there's a deficiency, so they took it out. And that you can't have, because that means an engineer looks at it and you say, oh, everything's fine. And then when it comes down to it, that everything's not fine, you will be blamed. So we put a table of contents in there. So if there's the pages are changed, we make it more difficult to change the table of contents. The tab project data includes the actual project data, who the owner is, what the address is, who the contact person was, mechanical engineer, their data, the mechanical contractor, who they were, who you were working for, the tab provider, your data, and the page number. And from this point on, we always put a page number on the page. So it's easy to see if someone has removed a page from the report, the page numbers will stay intact. So the certification page just simply mentions that it's got the project name, responsible tab technician or engineer who is on site, with their seal affixed to it, and they're basically saying that I guaranteed that I've done this job within the standards, and I guarantee the readings I have given in this report. And this is a standard disclaimer from one certification agency that puts in there, basically says that. The certification data has stamp and signature. So this is that has actually been certified by someone who is a certified individual and not just some technician off the street. Any project-specific certification statements that are required, and all of us all have our standard report pages, and again, a page number. Gotta make sure this hasn't been removed from the report. Tab summary page includes, this includes the project name, a brief description of the project scope, so you know what was actually in your scope. This is very important if you're doing a job that your scope is limited and they only did a piece of the job, say this turned out to be a remodel job, and you describe exactly what you tested. The reason this is important in a remodel job, let's say that you have a building with a big air handler and you're only testing half the rooms on that air handler. Well, there's a problem there, because you really need to go and actually set up the air handler itself, even though it's doing a part of the existing building. We would normally just pitot the existing part and then reset it up so that pitot is the same in our new part. But you understand that you have to do that air handler, so you need to expose what you're doing and what you're not doing. List of project testing notes, if there are any special notes about testing. A list of notes include construction deficiencies, includes tab testing issues. So this is part of the executive summary, where it tells what we did, how we did it, and what issues we found. And if they may even put in there issues that you solved, but how you solved them. And this could be important for the design engineer to see what went on and how he did that. And then there should be includes readings not in compliance. So if you've got some areas or readings that you just couldn't get to design flow, you need to make that known in the report. Now remember that our standard spec and our standard certificated agencies all have standard accuracies, which for tab is probably plus or minus 10% on airflows, and probably be something different on temperature readings, humidity readings, but on airflows plus or minus 10% for a reason. Now I've seen in recent years a lot of engineers try to limit that to plus 10 minus 0. So you have to be at design or better all the time. But what these people, they've never done balance obviously, but they fail to realize is our instruments have certain instruments, and some of them are plus or minus 5%, some of them are plus or minus 3%, some of them are plus or minus 2%, and some are plus or minus 10%. Well, to do a plus or minus 10% job, you need to have a plus or minus 5% instrument. You need to have about half the accuracy you're shooting for in your instrument. So this 0, 0 is impossible. You can't actually do it. And 0 plus 10 is possible, but that 0 is a problem. You're going to be overflowing everywhere to do that. So I don't understand some of those selections. I understand what they're trying to do. But in essence, a 2 or 3% difference in flow means almost nothing. It just means you have a slightly temperature difference. The TD changes slightly to make the load. Any project-specific certification condition statements. So if there's anything that prevented you from getting the flows and pressures that you were required to do, you need to lay it out here in your executive summary. It includes recommendations for corrections. If you couldn't correct it, you need to tell somebody how to correct it. And of course, page number is really important. This has a page number because this is the section the contractors would like to not include in this report. A lot of them feel it makes them look bad, but it doesn't really, because we expose this to them. If they choose not to correct it, that's their problem, not my problem. So anyway, that's exactly something that can get touchy. Now also, to make this better, every one of these deficiencies, they're also on the individual report. So you have it two places. You have it here on the deficiency list or the executive summary, and you have it on the page report specifically. So in case someone rips this page out of there, pages out of there, it's still on the individual reports. So the tab testing reports are all the reports you had on the job. They got the project name, the testing technicians, equipment ID, testing data, air distribution balance data, notes and remarks, including deficiencies. And of course a page number. And this would be and there's nothing special about these forms, but this is a typical air handler form, and it has all the data, unit data is up here and its flows requirements, and it's also got a picture with a pressure profile so you can see where the pressures are. You can do that or not do that. There's no standard for that. Or it could be one the same, but it has a grill and register totals down here. So how these reports look is not important, but what is important is the data they contain. So that's what they might look like. And remember, you could have literally hundreds and hundreds of pages here. We normally group them by systems. You can tell you got an air handler, then you got the grills and registers next. You got the exhaust fans next. You got everything in that zone you have all together, so the engineer can easily find his way around in that. It's what you decide to do. Then we have layout drawings. The layout drawings are important. The layout drawings are the mechanical drawings. They have unique equipment identifiers. They have the grill and registers identifiers, exhaust vent identifiers, so that you can relate what the numbers on the reports mean. And of course, they have page numbers. So here's a typical, it's a small layout job, and you can see that it lays out all the grills and registers have numbers on them, and all the equipment have IDs on them. Now, normally on the report, we use what the design engineer used for an equipment ID, but sometimes you can't do that because you have a job that has 500 heat pumps on it, and they selected 4 different types of heat pumps, so you have 140 number Ds, and you have 35 number Es, you have 10 Fs, and so you can't use that identification. You have to have a unique ID number for each piece of equipment, so you'd add your own. That's one of the main design review comments I make. As an engineer, you have to have unique ID numbers because there's a lot of people that need it, including the tab contractor, the control contractor, the electrician, and the owner. So it's foolish to do a set of drawings that you don't put unique IDs on. Now, we color code some of our drawings so things stand out, make it easier to read. This one was just the equipment, so you can see where the equipment was. But many times entire duct systems, like if you have a laboratory that has 4 or 5 different duct systems overlaying each other, we'll color code each duct system so it becomes very easy in the field to see which is which and where you're going. I have done jobs where the mechanical contractor got confused and hooked the supply to the return and vice versa. And it's real easy to catch is when your note pages stick to the supply grills, you know it's piped backward or ducted backwards. So we like to ID these, and we do a layout drawing for every piece of the job. Every mechanical drawing, except detailed drawings, will have a layout list, anything that has floor plans of an area. And this is so the engineer can see off your individual report pages which grill are we talking about, what unit are we talking about. It makes it easy to follow the project. Well, then resumes and certifications will include company tab certification, who are you certified by. It has names of technicians and engineers who performed work on the project. We'll have their resumes for each and what have they done, so you can the owner and design engineer can tell who is qualified and what they did on the job, and then individual certificates for the people that were on the job. So this makes your report full of what you're doing. Instrument calibration, a list of instruments utilized on the project, instrument data, which includes the model number of the instrument and what its accuracies are, calibration certificate for the instrument, so you'll have a recent in-date calibration for that instrument, and basically what instrument it was, and this is its calibration sheet. And you need to always include that because it's very important that you're using calibrated instruments when you do a project. So that's the report. Reports are easy, but reports are kind of the part of the job you may not like to do as much as actually doing the jobs, but this is one of the requirements to actually communicate with the owner and the engineer what you did on the project and how good a job you did. So what your report looks like is one of the best marketing things you can ever have. So do a good job in the report, make it look professional, and make sure your data is accurate. So thanks again for being a subscriber. Hope you have a great day, and I'll catch you on the next one.